For what non-zero real values of r does this series here converge? So we're adding up r to the 2 minus n. Now, the power of n in the expression makes me think maybe the root test could help us out. Okay. R can be any real number, though. It can't be 0. Okay? Because by the time you got n equals 3, you'd have r to the minus 1. That'd be 1 over r, so there's no way you could have 0 here. But the r values could be negative. So we can't just use the root test. We're going to have to use the absolute root test. So we'll use absolute root test. Okay, so we've got to calculate this row value here. N tends to infinity. The nth root of the absolute value of the nth term of the sequence we're adding up. Okay. So for us, I'm going to change the root n to a power of 1 over n. They mean the same thing, but you'll see why I do that in a moment. Absolute value plays nicely with multiplication, division, and since exponents are repeated multiplication, turns out we can pull the absolute value inside the exponent, okay, and then we can bring the 1 over n in, okay, and get 2 over n minus n over n, which is minus 1. Okay. Now, as n gets bigger, 2 over n is going to go to 0, so the limit in this case, because r is just a constant, an absolute value of r is also constant as far as n is concerned, it's going to be absolute value of r to the minus 1, or you could say 1 over absolute value of r. So that's our row value in terms of the r value. Okay, well, how does that help? Well, if row is less than 1, we get convergence. So we could rearrange this and say, all right, if r has an absolute value greater than 1, we get convergence. So you could say r is less than negative 1 or r is greater than 1. If rho is greater than 1, or even infinity, okay, then we get divergence. Okay, we'll rearrange this, and we're working with absolute value of r being less than 1. Okay, so we get divergence if r is between negative 1 and 1. And of course, r can't be equal to 0. But that does leave the situation where rho is equal to 1 and absolute value of r is equal to 1. So that's r is 1 or r is negative 1. And as is often the case with a sort of general find the values of r, find the values of x that do such and such question, when you use the ratio test or the root test, you're going to have a couple special cases left over. So if r is equal to 1, what are we doing? We're adding up 1 to the 2 minus n, but the nth term test should help us. In fact, the nth term test will help us with both of these. Okay, so we'll say nth term test. Okay. The limit, as n tends to infinity, of 1 to the 2 minus n is just going to be 1. This isn't 0, so we get divergence. Similarly, if r is negative 1, we don't even need to write what exactly it is. The nth term test is going to help us here. Okay. We get negative 1 to the 2 minus n, and the limit here just doesn't exist. It bounces back and forth between 1 and minus 1. But once again, nth term test tells us divergence. Okay. So what can we conclude? We were just asked, I believe, only about convergence, but you do have to know where it diverges to know that you haven't missed a convergence case. Okay. So we'll say that this series is convergent if r is less than negative 1 or if r is greater than 1. And it's divergent for any other non-zero real value.